auxiliary angle. So here we're going to have a look at how we can take an expression involving a sum or difference of two trig functions and turn them into one trig function. And we're going to do this using our compound angle results. So we're going to use either sine of theta plus x equals sine theta cos x plus cos theta sine x, or sine theta minus x equals sine theta cos x minus cos theta sine x, or cos of theta plus x equals cos theta cos x minus sine theta sine x, or cos theta minus x equaling cos theta cos x plus sine theta sine x. And I'm just going to make a small difference to these equations by multiplying both sides by r in all of the equations, and that's going to give us r here, an r here, and an r here. So multiplying both sides of every equation by r to give us this result here for our compound angle formula. And we're going to use these results to help us solve equations like this. So let's have a look at an example. So we're going to need to solve cos x minus root 3 sine x equals 2. And the way we're going to do this, we're going to just take our left-hand side, which is cos x minus root 3 sine x, and we're going to make it equal to one of these equations. Now, the equation that we're going to make it equal will determine if we've got a positive or negative here, and we have a cos term minusing a sine term, so we're going to use one of these because they have a negative in the middle, and we could actually use any, but I'm going to go ahead and use this second one here. We could use any of these two, but I'm going to use the second one. Technically, you could actually use any of the four, but just to make things a bit easier, we'll use the one with a negative in it already. Now, I'm going to write the right-hand side of the second one. So it's going to equal r sine theta cos x minus r cos theta sine x, which also equals r sine of theta minus x. Now, just looking at this part of the equation here, we want to equate coefficients. So for this to be true, we're going to look at the coefficient of 1 here, and we need the 1 to equal all of r sine theta. And for this equation to be true, we need root 3 to equal r cos theta. So let's go ahead and write that down. So we need 1 to equal r sine theta, and we need root 3 to equal r cos theta. And we need to solve for values of r and theta. So what we can do is we call this one equation 1, and this one equation 2, we just need to solve simultaneously. So we're going to go ahead and do 1 divided by 2. So we're going to get 1 over root 3 equaling r sine theta over r cos theta. The r's will cancel out, and we just get tan theta. So sine theta over cos theta is going to be tan theta equals 1 over root 3. And solving for theta, we're just going to get theta. So we're supposed to solve this equation where x is greater than or x is between 0 and 2 pi. Because that tells us that we need an answer in radians and not degrees. So doing the inverse tan of both sides to give us theta, we're going to get theta equals the inverse tan of 1 over root 3, which is going to give us theta being pi on 6. Now that we know theta is pi on 6, we can solve for r, so we can go ahead and sub it into any of the equations. So we'll sub it into sub it into equation 1. So we'll get 1 equals r sine of theta, which we now know is pi on 6. So that's just 1 equals r times sine of pi on 6 is a half, times both sides by 2. So we get r is equal to 2. And the reason this is going to help us out is because this equation equals this equation, which equals this equation. And now we know the values of r and theta. So now we can express our left-hand side of the equation of cos x minus root 3 sine x as r, which is 2, times sine of theta, which is pi over 6, minus x. And this is the same thing as this. So now we can sub this into here and make it equal 2. And this is going to make it a lot easier to solve for x. So we're going to have 2 sine of pi over 6 minus x equals 2. We can divide both sides by 2. So we'll have sine of pi on 6 minus x equals 1. Take the inverse sine of both sides. So we're just going to be left with pi on 6 minus x equals the inverse sine of 1. So pi on 6 minus x equals the inverse sine of 1 is just pi on 2. So we can minus pi on 6 from both sides. So we get pi on 2 minus pi on 6. So we're going to get pi on 2 minus pi on 6. That's the same thing as 3 pi on 6 minus pi on 6. So we're going to get minus x equaling 3 pi on 6 minus pi on 6 is 2 pi on 6 or pi on 3. So x equals minus pi on 3. But this answer is not within the domain. So if we do get a negative answer, we just can add 2 pi here, because always adding or subtracting 2 pi to our answer for trig functions gives us the same value. So then adding 2 pi is the same thing as adding 6 pi on 3. So then we're going to get x equals 5 pi on 3 for our solution.